Okay, we're doing section 5.1, new chapter, learning about polynomial functions. Polynomial functions include linear functions and quadratic functions and other functions that are smooth and continuous and have exponents that are not negative or fractions. Okay, so here's a definition. Made of terms. Do you guys know what a term is? A term is where you have like a coefficient and a variable, and the variable might have an exponent, and then those terms are adding and subtracting in your function. Sometimes a function only has one term. Sometimes the term only has a number and doesn't have a variable. But it's basically just the pieces that add and subtract within an equation or a function. Made of terms with exponents that are non-negative integers. Okay, so for example, f of x equals 2 minus 3x to the fourth would be a polynomial function. Or this one, h of x equals negative 2x to the third, x minus 1 squared. Of course, you could FOIL all that stuff out and get a nice, pretty function. So in other words, polynomial functions are not functions that contain square roots or fractions. And I guess I better be careful when I say fractions. That means, you know, the numbers, the coefficients can be fractions, but you wouldn't have a fraction with x stuff in the denominator. Okay? Roots or fractions. So, for example, such as g of x equals the square root of x, or y equals 1 over x. Those are not polynomial functions. Okay? One of the main characteristics of polynomial functions is that they are the graphs of polynomial functions are smooth and continuous. There are no holes, no asymptotes. Graph is smooth and continuous. And since there are no holes and no asymptotes, the domain is always, always, always all real numbers. So from negative infinity to positive infinity, that's always the domain. Now the range may or may not be the same. It depends on if it has minimums or maximums that cause it to only go up or down to a certain amount. Okay, the degree of a polynomial is a name we give to different functions. We'll say this polynomial function is degree 4 or degree 5 or degree 3. The degree of a polynomial is given by the highest exponent. So because of that, quadratics can be called degree 2 polynomials, and linears can be called degree 1. But then, of course, we're also going to be working with degree 3, degree 4, possibly even degree 5 polynomials. Okay? Next word I want to talk about is the word zero, or zeros of a function, of a polynomial function. Actually, the zeros of any function are the x-intercepts. The reason they are called zeros is because that is where the y value of the function is 0. Where the value of the function, so in other words, the y value equals 0, and that's why it's called the zeros. Okay? Another name we sometimes use for zeros, also known as roots of the function, Or if we're solving an equation that's a polynomial equation, or it looks like a polynomial function, but we're solving it instead. So instead of having y, it has like a number like 0. Then those x-intercepts, or zeros, or roots, are also the solutions of the function. And we'll talk more about that when we get to section 5.5, I believe. Okay? All right. Let's do an example where we find the zeros of a function. Okay, here it is. Y equals x squared minus 7x plus 10. Well, since the zeros of the function are just the the x-intercepts, where y equals 0, we can simply place 0 in for y and solve for x. In this case, we're just solving a quadratic. The two ways that we generally use to solve quadratics are either by factoring, if it will factor, or quadratic formula, if it does not factor. So this one, factoring works great, so let's do that. So factor our x squared, that means we have to have an x and an x in order to FOIL this back together to get x times x is x squared. And then we need two factors of 10 that add up to negative 7. So a negative times a negative equals a positive. So as long as these are both negative, we'll multiply them to get that 10, but we need them to add up to the negative 7. Well, the obvious factors are 5 and 2. Okay? So then we use the zero product property, and we discovered that if we take each of the zeros, each of those factors, x minus 5 equals 0, then one of the zeros is 5, and x minus 2 equals 0, then the other 0 is 2. So the 0 is always the number that within the parentheses of the factor will make that answer 0. So that means graphically, which we're going to need to understand more about as we go along, graphically the x-intercepts are at 2 and at 5. So, we learned this earlier in chapter 4, that we can find the x-intercepts, we can find the vertex, we can see whether the parabola opens up or down, and all of those details help us to be able to graph that function, okay? So we're kind of just using a different name for the x-intercepts, zeros, instead. I don't know why they have us learn so many different names for all of the things, but they are ones you need to know what they are. I'm going to stop at this point just to separate out my videos a little bit.